Hi guys, so today we are on day 2 of our online instruction. So today we're going to continue with rational expressions, except today instead of multiplying and dividing, we're going to add and subtract. So usually adding and subtracting is easier than multiplying and dividing, but in this case, with fractions it can be a little bit harder, because as you know, in order to add and subtract fractions, we have to have a common denominator. So just to review, adding these two fractions on the left, that common denominator would be 35. The left fraction, you'd multiply top and bottom by 5. Right fraction, you multiply top and bottom by 7. And then once I have that common denominator, then I can go ahead and subtract those values. And again, the denominator is going to stay the same. I would just subtract the top, which is going to give me a negative 27. Now remember with a fraction, that negative 27 over 35, that's the same thing as saying the whole fraction is negative. It's also the same thing as if that negative were in the bottom. So you may have some answers that are similar but are different kind of by where that negative is placed. Keep in mind those are still equivalent. All right, now one thing that's going to help you out today is making sure you specifically get the least common denominator. Now if you want, you could multiply the top and bottom by 18 of this one and top and bottom of this one by 12. And you are going to get a correct answer that just needs to be simplified. But the math behind that's a little bit messy. So what is really going to be important is for us to get the least common denominator. In that case, this one is 36. So the left fraction would need to get multiplied by 3. The right fraction would need to get multiplied by 2. Once you have that same denominator, we can add, and again, this one does not simplify, so we're done. So we're going to apply the exact same concept to rational functions. So the first thing we need to do is identify what that common denominator is. Well, this first one's pretty simple. We already have a common denominator. Both rational expressions have a denominator of x squared. So all I need to do is subtract the numerators. The denominator is going to stay the same. Now you need to be careful though whenever you subtract. Whenever you subtract, you need to remember you are subtracting the entire numerator. So this would be a negative 3x, and it's got to be 3 minus negative 4. Which is the same thing as 3 plus 4, which is 7. Now, just like we did with multiplying and dividing, we're going to also include any excluded values. Now, these will be a little bit simpler than they were with multiplying and dividing because our denominators aren't really going to change. Whatever our denominator is, that's going to be our denominator. So in this case, x is not equal to 0. Again, order here and the way you write it, there's a couple different things that are equivalent. You also could write this as 7 minus 3x over x squared. Either one of those is okay. All right, so now let's look at one that does not already have a common denominator. So if that's the case, our first step when we do these problems is going to be to factor. So I'm going to start, remember GCF does need to be considered. So this would be x minus 3 and x minus 1. So now what I'm going to do is I'm going to look at my denominators and see what each fraction is missing. Well, the right fraction has an x minus 1. Sorry, the right fraction has an x minus 1. The left fraction has an x minus 1. So those are included in both. So we don't need to add that to any other ones. The left fraction, though, does not have the x minus 3. So what I need to do is multiply top and bottom there by x minus 3. All right, then the right fraction, it has the x minus 3 and the x minus 1. It doesn't have the 2. So that also needs to get multiplied by 2. Top and bottom. So now I'm just going to rewrite what I have. So x minus 3 times x plus 2 over my new common denominator. And then at this point, we need to go ahead and simplify and combine these together. Now, we talked when we did multiplying and dividing about the format of our answer. The numerator and the denominator need to be either fully factored or fully multiplied out and written in standard form. Either option is okay. So for your denominator, you're not going to want to FOIL that out. That's a lot of extra work. So we're going to leave our denominator in factored form. It's just going to be easier to work with. Our numerator, though, what I can't do is just leave the numerator as this. because that's what we're talking about, where it's kind of factored, but not fully factored. Because again, you now have a term and a term. So it's not fully factored. So we can't leave our denominator or numerator just in that form. The other thing we need to be careful about that I've noticed just from some people is they do this first step and then they look at what they have and they're like, oh, look, I can cancel out x minus 3. While you can do that, we don't want to do that. We intentionally multiplied by x minus 3 so that we would get that common denominator. So at this point, our next step is just going to be to multiply out whatever we have in our numerators. So I'm going to go ahead and FOIL out the top. So that's going to give me x squared minus 3x plus 2x minus 6 over that common denominator. And again, I'm going to leave the denominator factored because it's going to stay consistent and it's fully factored already. All right, then I'll FOIL out this part. I've got negative 4x minus 2. Then at this point, I can go ahead and combine these two fractions together and combine like terms to simplify. So again, because it's subtraction, I need to remember I'm subtracting the entire quantity. That's probably the biggest mistake in these questions is with subtraction. So what I'm going to do is I'm going to change this to plus and change my signs. Then I can go ahead and combine those numerators together. I'll go ahead and make that negative x. Then I can simplify the top, and I end up with x squared plus 3x minus 4 over 2 x minus 3 x minus 1. So again, the form that you use here, you've got a couple options like we said. I've got the top is in standard form, the bottom's in factored form, and as long as it's fully factored, it's okay. Now this one's pretty unique. It's kind of a special case. So I want you guys to actually look at this. Look at the new numerator that you have. And I'm going to rewrite it up here at the top so we can see it a little bit better. So I was left with x squared plus 3x minus 4 over 2 x minus 3 x minus 1. So that was what I ended up with. While that's a really good answer, and typically that is where we're going to stop, it's actually not the case here. Because what you guys know, x squared plus 3x minus 4 does factor. A lot of times the answers that you get are not going to. In this case, it does. What's even more unique about this problem, not only does it factor, one of those factors is in the denominator. So I can go ahead and factor the top. Let me use the different colors you guys can see here. So that top factors into x plus 4 and x minus 1. So now that x minus 1 factor is going to be able to cancel out. So my final answer here would be x plus 4 over 2 x minus 3 with an excluded value of 3 or 1. So again, kind of a unique case here where, first of all, the numerator was factorable after we were done, but not only was it factorable, it actually included the same factor as the denominator. It's not super common, but it is something we do want to check for. Again, if you wanted to write the bottom as 2x minus 6, that is also okay. Either way is fine. All right, let's do a couple more. All right, so again, first step here is to factor. All right, so factoring this left fraction, that's x minus 4 and x plus 3. The right, I can factor by taking out a GCF. Always take your GCF first. You may miss or make a more complicated denominator if you don't. All right, so now let's see what these fractions need to have that common denominator. Well, the left fraction is missing the 12. So I'm going to multiply by 12. The right fraction is missing the x plus 3. So that leaves me with 12x over this common denominator. And I'm going to go ahead and FOIL out because it's pretty easy just distributing. And then at this point, now that it's simplified, I can go ahead and combine the numerators together, combine like terms. So that gives me 17x plus 15 over that common denominator. So again, this one's more similar to what you'll probably see more often. The numerator doesn't factor again, but again, it's just something to watch for and make sure. Let's go ahead and list our excluded values, Okay, anything that makes the denominator 0, remember, is an excluded value because we cannot divide by 0. All right, on the next one, this is another case where it's really helpful to find the least common denominator. So again, factor the left, 3x comes out, that leaves me with x plus 1. So you could look at this and say, hey, this left fraction needs a 3x and an x plus 1. And you'll still get to your answer, but it's going to be a lot harder to get there than it would be if you find the simplest denominator. And what I mean by that, in order to get 9x squared on this right fraction, I don't need to multiply by 9x squared. If I take 3x and I multiply it by 3x, that's going to give me 9x squared. So then the right fraction only needs to get multiplied by 3x top and bottom. Well, now I have a 9x squared in my denominator. The left fraction just needs x plus 1. So again, least common denominator here is kind of the key. It's going to make your math a lot easier. It's a lot less multiplying for us to do, a lot less simplifying in the end. So now that left fraction becomes 7x plus 7. That right fraction becomes 3x squared. And again, 3x times 3x is 9x squared. I have a common denominator. I can combine my numerators together. Let's see if the top factors, just to make sure nothing cancels. And there is nothing that multiplies to 21 and adds to 7. So at this point, we are good. List your excluded values. So one factor could be 0. The other one is negative 1. And we got our answer. All right, so there's one more that we're going to look at. This is another kind of special case. And this deals a lot with what we talked about with kind of with your placement of your negatives. So if you notice, again, least common denominator is going to make this the easiest problem. You may say, hey, let's multiply this by 4 minus x, and let's multiply this by x minus 4. So you're going to get a lot of extra work, a lot of extra foiling. It's going to be really messy. The easiest thing to do here, if you notice 4 minus x, we talked about this in the last video, 4 minus x is the same thing as negative x plus 4. Well, I can factor out that leading negative and rewrite it like this. Well, that's the exact same thing as the first fraction. It's just missing a negative. So I'm going to rewrite this as negative x minus 4. So now to get a common denominator, all I have to do is multiply by a negative 1. So now my new fraction is a negative x squared minus x plus 27 over negative parentheses x minus 4. I have a common denominator. I can combine the numerators. Negative x squared plus x squared is 0. Negative 9x is left. 27 plus 9 is 36. And again, this is another one of those kind of unique cases where I can still factor the top. And not only can I factor the top, when I do, a factor cancels out. So I'm left with negative 9 divided by negative 1, which is just 9. Now, since we're left with just a single number, if typically we write those excluded values, so x is not equal to 4. That's true, x can't equal 4, but if you look at your answer, we don't have any x's, okay? It's just the number 9. Basically, what that's telling me is whatever number I plug in for x, I'm going to get 9. That's what this equation simplifies to. So we don't need to include this. It's not wrong if you do, but it really doesn't affect our answer because our answer doesn't have a 9 in it. All right, so that is it for adding and subtracting. Again, make sure you factor first, get a common denominator. Once you know that denominator, then FOIL out the numerators and then combine and simplify the numerators. The